Those that aren't in attendance are able to view this later. So I'm going to go ahead and hit record on here, and we're going to go through. So basically, phase 4 of this meeting or of this class is looking through the Math 3 released exam. And the reason we would look through the released exam is because so that those that aren't in attendance are able to view this later. So the reason we would look through the released exam is because we would want to go through, and the release exam shows the key important things that you should have learned from the class and basically what you would have been tested on if we would have had the exam. So these are kind of like things that we hope that you'll get and learn and carry with you into the next class. If you were able to pick up a packet, then that's great. And you have that for this exam or for this week. If you were not able to pick up a packet, then what I'm going to do is I'm going to show you where you can find this information. So I'm going to upload this file into Canvas, and then I'll share my screen with you, and you'll be able to find that form there in Canvas as well. So I'll keep you updated with that. So yesterday, was the packet pickup. If you weren't able to go by and pick those up, then I'll show you where that's at. So let me share my screen with you for this. If you look on, as I'm sharing it with you, if you look on our class page, I've created a link for this week, May 18th through May 22nd. Remember, our last day of class is Friday, so Friday will be the end of these meetings. So as we move towards the end of the semester, basically here it says EOC NC Math 3 released form. And if you'll click on that or hit the preview button, then what you'll see is the packet that I left for you to pick up for this last phase. So basically there are 30 questions on here that take you through what the Math 3 exam would look like and take you through all the information that they feel like you should kind of know for this class. Couple things. So let me go over this as well for those of you in attendance and the people not viewing today. So what's going to happen is I'm going to go back into your Q3 grades as well, and I can add up to 5 points to your grade if you followed along and done things like that. And basically, I will add the 5 points, and then I need to be in contact with you about whether you want to take the number grade or it to be a pass as your grade for the class. There's really no reason to take a pass unless you feel like the grade is too low and you don't want it to affect your GPA. But if you have a solid grade in the class, then you would want to take the number grade with those 5 points added. And I will be putting those into PowerSchool so that they can be updated. But I'll be sending out like a survey for you to respond to this week that says whether you would like to take the number grade or to take the pass, and that will allow you to kind of know which one, so you can tell me which one that you want. But I would assume most of you with high grades are going to take the number grade because that's going to be the one that shows all the work that you've done this semester. Okay. Your other teachers from your other classes should be contacting you at some point to be asking you the same question. And again, I would say the same thing. If you think if your grade's high enough and you're happy with it, then I would put the number grade on your report card. And if for some reason you just did not do up to your capabilities and it's really low for some reason and that's out of character for you, then maybe you want to take a pass on that one, and you'll still pass the course, but it will not show your number grade on there, and it would not affect your GPA. Okay, so you need to think about those things. All right, so sharing this with you today, we're going to go through about 7 or 8 problems today, and then we're going to continue to do the same thing through through the end of the week. So the goal is to get through these 30 questions. We usually do this in class together as well as a review, so we would have been doing the same thing if we were in a face-to-face classroom. So what we're going to do at this point is start with these questions. So if you have your packet that you picked up, this is the very first page. These are the released items that they published just a little over a year and a half ago in the fall of 2018 when the NC Math 3 course became an EOC, so one of the big exams in high school. And these are the released questions that they gave for this. So let's look through these. We're going to start with question number 1. We're going to hope to get through about 7 or 8 today. And again, if we go through about 7 or 8 each day, we will finish all 30 by Friday, and we'll be done. So let's look at question number 1. Question number 1 says, what is the remainder when x to the third minus 1 is divided by x plus 2? And does anybody remember? So the first thing I want to ask is, does anybody remember what we'd be doing in this type of question? What would this type of question require us to do in order to solve? So think about it. We're taking a polynomial and we're dividing. So what would we be wanting to do here to solve? It's quiet today in the chat. Let's see what's going on. What type of division did we learn in this Math 3 course? Somewhere in the middle. Yep, that would be synthetic division. Absolutely. All right, so let's look at synthetic division. So in synthetic division, I'm going to go back and I'm going to share with you my whiteboard. So we're going to take x to the third minus 1, and we're going to divide it by x plus 2. Okay, so that is that's our problem. That's our synthetic division. So x to the third minus 1 divided by x plus 2. So as we make a box, what number are we going to put in the box here? So we make a box to put a number there, and what number would we put in the box if we try to remember synthetic division? Are we going to put a positive 2, or are we going to put a negative 2 in the box? We're going to put the opposite, right? Because it's x plus 2 equals 0. That would mean x equals negative 2. So we put a negative 2 in the box. And then we start with our coefficients. X to the third is 1, so we have 1x to the third. Now remember, this one skips. So this was the trick where you can't just write them down. It skips the x squared power. So the second power, we have 0 x squares. We have 0 x's. It skips that power as well. And then for the number, we have a negative 1. So we had 1x to the third, and we had 0 x squares. We had 0 x's, and then we had the number negative 1. Okay, so now we are going to bring the first number down. That first number is a 1. We bring it down below the line, and we're going to multiply. So negative 2 times 1 is negative 2, and then we're going to add 0 plus negative 2 is negative 2, and then we're going to multiply. Once we get below the line, negative 2 times negative 2 gives us 4. And then we're going to add 0 plus 4 is 4. Then we're going to multiply. -2 times 4 gives us -8. And then we're going to add -1 plus -8 ends up with -9. Okay, so that is our final answer. Now we have to make that into an answer choice on here. And the way we make that into an answer choice is we see that we started with x to the third power. So our answer is going to start 1 degree less. So that's 1x to the second power minus 2x plus 4. And then this -9 is our remainder. So we're going to write it over what we're dividing by, which is x plus 2. So we end up with x squared minus 2x plus 4, and then minus 9 over x plus 2. Now, if I go back to the problem, if you look on here, these are gridded response or free response questions. So you basically, and the question asks, what is the remainder? So the only thing we needed to know for this one is what is the remainder? And so we would have typed in -9. So the remainder is -9. That's our remainder for this problem. And that's what, and this would be not a multiple choice. So this would be one where they would be typing in, you would be typing in your response. Okay, so let's go to number 2. Number 2 says, the function below, f of x, has x minus 7 and x plus 4i as factors. And then it gives you the equation down here below. It says, what is the total number of real zeros of f of x? First of all, we need to know what a real zero is. So a real zero is whenever it crosses the x-axis. So we're looking for, our key here today is we're looking for when does this graph cross the x-axis? How many times? That would be the total number of real zeros. So when we graph this, how many times does it cross the x-axis? So to graph it, we're going to go to desmos.com and we're going to go to start graphing. And we're going to look at our equation. So it's 2x to the 5th minus 13x to the 4th. Let's keep going. And then it's plus 22x to the 3rd minus 187x squared. And then it is minus 160x plus 336. Okay, so even if I zoom out, I can easily see in Desmos, it crosses the x-axis at 7, it crosses the x-axis at 1, and it crosses the x-axis at -1.5. So how many real zeros would I say that this equation has? How many real zeros in this equation specifically? Remember, a real zero is just when it crosses the x-axis. So when I ask you how many real zeros there are, I'm just asking you how many times does it cross the x-axis. And yes, it crosses the x-axis 1, 2, and 3 times. So there are 3 real zeros. So I go back to the problem. It says the function below has this as factors. Here's the function. What is the total number of real zeros? And that would be 3. Now, the tough part of that problem is if it would have just said how many times does it cross the x-axis, most people would have got that. But because it uses this vocabulary of real zeros, remember, zeros, roots, x-intercepts, solutions, those are all similar things. Those are all basically the same. And so we can use any type of vocabulary to describe those. So in this case, they use the term zeros of the function. So what is the total number of real zeros? All right, that was number 2. Let's move down to number 3. Number 3 is very similar in what we're looking for here. It says the graph of the function, x to the third plus 3x squared minus 2x minus 4, has a 0 at -1. What are the other zeros of the function? So we know it crosses the x-axis at -1. We want to know where else does it cross the x-axis. So we're going to type this in, x to the third plus 3x squared minus 2x minus 4. And so when we type it in, first of all, it already told us that it had a 0 at -1. So now we're just looking for what are the other two zeros. So this one says -3.236, and this one says 1.236. So if I look at that, I know that's not A, and I know that's not B. So I'm looking for, is this C or D? So the way I'm going to be able to do this is I'm going to type in, what is -1 plus the square root of 5? And you could also be typing this in on your calculator as well. It would make no difference as to which one you're typing it on. And that is 1.236. -1 plus the square root of 5 is 1.236. And then -1 minus the square root of 5 is -3.236. So you can see how those are the two answers there for that equation. So you get -1 plus square root of 5 and -1 minus square root of 5 are my other two options there in number 3. Those are the other zeros of the function. All right, so we move forward now to question number 4. Question number 4 says, which expression is equivalent to x squared minus 2x minus 37 divided by x squared minus 3x minus 40? So again, I like to use Desmos. So we're going to go in and we're going to say x squared minus, and we're going to look at these, 2x minus 37 divided by x squared minus 3x minus 40. Okay, so there is the original equation. And then we can look at these. 1 plus x plus 3. X squared minus 3x minus 40. So now here is how you get your answer here. So anyways, this is answer choice A. So what I would like for you to see is if I click away on answer choice A, hopefully you will see that answer choice A goes directly on top of the equation. That means it is the same equation, okay? If I would have typed in answer choice B, which is 1 minus this, let's say I change this to 1 minus, then you would see in answer choice B that that is not the same equation. So it's not equivalent to that, okay? It's not equivalent to the equation. But in answer choice A, when I say 1 plus that, and then I put that equation there, it sits directly on top of the original equation, which means it is the exact same equation, okay? And since it is the exact same equation, then we know that that is the answer. So question number 4, our answer would be A, 1 plus x plus 3 over x squared minus 3x minus 40. And that is how I would work that, is through Desmos.com. Okay, so let's move now to question number 5. Question number 5 says, this is a paper pencil copy of an online technology enhanced item. So basically, they give you 4 choices for each thing, and they want you to find the final answer, which is ax squared plus bx plus c. So if you look, this is in our rational equations section. This is one of the units that we did as we were working from home. This fraction has 4x plus 3 as its denominator. This fraction has 7x minus 2 as its denominator. So we need to multiply 4x plus 3 into this fraction, and we need to multiply 7x minus 2 into this fraction. So we have 3x minus 5 times 7x, and let me clear this out. So we have, let me go back to the problem. We have 3x minus 5, and we're going to have to multiply 7x minus 2 with it. And then on the other side, if we go back to it, we have negative 2x plus 1, and we're going to have to multiply the 4x plus 3 to go with it. So negative 2x plus 1 and 4x plus 3. Okay, so this is the box method, right? We're going to use FOIL or the box method to multiply these. So if you make a box, you've got 3x, you've got negative 5, you've got 7x, you've got negative 2. Over here, you've got negative 2x, you've got a positive 1, you've got 4x, and you've got a positive 3. So we're going to multiply. So we have 21x squared, we have negative 35x, we have negative 6x, and we have positive 10. Okay, so we're going to take the box method and we're going to complete this. The only thing we need to do is combine like terms right here. So we have 21x squared minus 41x, because we're combining the negative 35x and the negative 6x, and then plus 10. Okay, that's our first answer for the left part. Okay, now let's do the right part. Negative 2x times 4x is negative 8x squared. 1 times 4x is 4x. Negative 2x times 3 is negative 6x. And 1 times 3 is 3. So we're going to only be able to combine the 4x and negative 6x. So we have negative 8x squared. 4x and negative 6x would be negative 2x. And then we have a plus 3. Now, if you look, we want to add these together because this was a rational equation. So 21x squared and negative 8x squared gives me 13x squared. Negative 41x and negative 2x gives me negative 43x. And then 10 and 3 gives me 13. So 13x squared minus 43x plus 13. So I pick 13 for the x squared, minus 43 for the x, and 13 for the number at the end. And that is my final answer for question number 5. So basically, all we were doing was multiplying in what each problem was missing. So we were just multiplying in what each one was missing from the bottom. So what were they missing from the denominator? And then when we did multiply that, it set up 2 binomials for each one, which made us do the FOIL or box method to solve. All right, so let's go back to our Math 3 questions. Let's go to question number 6. It says, which expression is equivalent to this? So let's look at it first. I'm going to write directly on this question number 6 because these all have negative exponents. But the first thing that I notice in question number 6 is a division sign. Anytime you see a division sign in rationals, we want to flip the second fraction. So let's go ahead and do that first. So I'm going to say x squared minus 5x plus 6 to the negative 1 over x minus 2 to the negative 2 times, instead of divide, x minus 2 to the negative 2 over x minus 3 to the negative 1. So you see, I just flipped it. Now, they all have negative exponents. So what I need to do now is flip them to make them positive. So it's going to be x minus 2 squared over x squared minus 5x plus 6 to the first power. I don't have to write anything there. And then it's going to be x minus 3, so I don't have to write anything there, over x minus 2 squared. And what you'll notice immediately is the x minus 2 squareds will cancel out. So we're able to cancel out x minus 2 squared here and x minus 2 squared down here. And we have an x minus 3 up top. On the bottom, we have an x squared minus 5x plus 6. So we've got an x minus 3 on top. And on the bottom, we've got x squared minus 5x plus 6. So what two numbers multiply to give me a positive 6 and add to give me a negative 5? What two numbers multiply to give me a positive 6 and add to give me a negative 5? Right, negative 2 and negative 3. So I'm going to say minus 2 and minus 3. At that point, you see the x minus 3's will cancel out. So we're left with nothing on the top of the fraction. So we put a 1. And on the bottom of the fraction, we're left with x minus 2. So 1 over x minus 2. That would leave our answer for question number 6 as D, 1 divided by x minus 2. Okay, so there's question number 6. So I'm going to clear that off. Again, in question number 6, what happened was it was division. So we flipped the second part first to make it multiplication. And then because all of these had negative exponents, we flipped each fraction so that they now had positive exponents. That allowed us to cancel out the x minus 2 squares. We factored the x squared minus 5x plus 6. And then that allowed us to cancel out the x minus 3's. Okay. So we're going to go to question number 7, our last question of the day on here. And then we're going to play a little game on here. But question number 7, a company makes and boxes spaghetti. One machine fills each box with approximately 32 ounces of spaghetti. After the boxes are filled, another machine weighs each box. A box is discarded if the weight of the box differs by more than 0.25 ounces from the target weight of 32 ounces. Which inequality can be used to find the range of acceptable weights of the spaghetti? And this is just a formula that we kind of learned a long time ago, but it's x minus the ideal is less than or equal to the tolerance. Okay? So ideal is the amount that you would want it to be, your target. Sometimes they say x minus the target, but x minus the ideal or the target weight. So the target weight, it says, is 32 ounces. It gives you that twice. So we know it's x minus 32 is less than or equal to, and tolerance is how much you're going to tolerate it being off. So it's okay if we have this much error. And the error that we're okay with is 0.25 or less. So 0.25. So the absolute value of x minus 32 is less than or equal to 0.25. And there we are with C for question number 7. Again, if you think about it, if you put the number 33 in for x, you get 1 is less than or equal to 0.25. So it's not, 33 would not be acceptable. An acceptable weight would be something between 32.25 and 31.75, meaning it's not off by any more than 0.25. So it's less than or equal to 0.25 away from 32, because this at the bottom is saying what's the difference, how far is it from 32, and it needs to be less than or equal to 0.25. So like 32.1, you say 32.1 minus 32, that's 0.1, that's less than or equal to 0.25. So 32.1 is an acceptable weight, okay? So that's what we're looking for as far as our range of acceptable weights. So I want to make sure that as we're doing these, you're going through and answering and writing these down, writing the notes for it so that you know how to work each problem as you go through these. That's one of the goals that you want to do is make sure that you can actually complete each problem fully as you. That's one of our main goals in this as well. The next thing that we're going to do, if I log in, is we're going to play a quick, just a little game, just looking at a few things from Math 3. So specifically, we were looking today at polynomials, and we were in a few problems, and we were looking at the graphs of the polynomial and what they would look like. So let's go through really quickly, and let's look at the polynomials and see which one works. Okay, so let's see if we know polynomials well. So we're just going to do a quick little game for polynomials. Okay. So let me share with you my screen so that we can finish this. And here you go. So I'll give you just a couple minutes to 2 minutes to join on, and we'll play this game, and then we will end our session today. Our first review, 1 through 7, is the questions we did today on the NC Math 3 released exam. So you can join this game at www.kahoot.it or with the Kahoot app on your phone. The PIN number is 9507672. Okay, a couple more seconds, and then we're going to go ahead and start. And here we go. So let's focus on polynomials today. Question 1, what is a binomial? A binomial is a polynomial with two terms. So remember, a term is just one part of the polynomial. So for instance, like a binomial is one of the things we were multiplying together on that problem where we had to do the rational equations. So 7x plus 2 is a binomial. 3x minus 4 would be a binomial. It has two terms. Question 2, what is a constant? So a constant is a fixed number. Some people said a coefficient. So a coefficient would mean it's in front of a variable. So a coefficient, like if it's 3x, the coefficient is 3. A variable is x, y, or z, like a actual letter. So a fixed number is a constant, like the number 10, the number 20, something like that. That would be a constant. Number 3, what is a term? What is a term? A little tricky. A term is a number or variable separated by a plus or minus. So like I said, 7x plus 4 has two terms. It's a binomial. 7x is a term, and 4 is a term. Question number 4, what is the degree of an equation? Absolutely. So the largest exponent is going to be your degree, sometimes referred to as your power. What is a trinomial? So a trinomial has three terms. So for instance, 7x squared plus 5x plus 8. That would be a trinomial. It doesn't have anything to do with the degree. Remember, if something had a degree of 3, we would actually call it a cubic. Remember, a quadratic is something with a degree of 2. Linear is a degree of 1. So it doesn't have anything to do with the degree. It has to do with the number of terms. So a trinomial is a polynomial that has 3 terms. Question number 6, what is a coefficient? Remember, we just talked about this. Good. Coefficient is the number that goes in front of the variable. So if it's 5x, the coefficient is 5. Remember, when we're doing synthetic division, we're told to always write down the coefficients, and those are the numbers that are in front of the variables. Which one of these words is not a vocabulary word in polynomials? Which one is not in polynomials? Trilobite is actually the answer there. I don't know what that is, but that is not in polynomials. Number 8, which one is not a polynomial? Okay, a lot of people missed this one. All right, now listen. 5 is a constant monomial. So it's a constant because it's just a number. It's a monomial because there's one term. So it is definitely a polynomial. X to the negative 4 is not a polynomial because you can never end with a negative exponent. So there is no such thing as x to the negative 4. It would be 1 over x to the 4th because you would have to move it to the bottom of the fraction. Okay, so this is a quadratic binomial. This is a cubic binomial. This is a constant monomial. Number 9. It is false. 5x squared minus negative 2x squared. So 5 minus negative 2 is 7. That would be 7x squared. And then 6x minus 2x would be 4x. So it should be 7x squared plus 4x. And lastly, the degree of this equation is good job, everybody ended with a good one there. So the highest exponent in this equation is 5, so this equation goes to the 5th power with a degree of 5. So we go to the podium. Elizabeth got 8 out of 10. Good job, Judy. Giselle with 8 out of 10. Also, just barely, And Carpenter with 9 out of 10. So everybody missed at least one. So hopefully, Caitlin and Crystal not far behind. So hopefully everybody learned a little something from today's lesson, as you guys did. You guys did miss at least one as we went through those. So we'll work on another topic tomorrow after we go through some problems. So we finished 1 through 7. Make sure you followed along on that. We'll come back tomorrow and go through questions 8 through 15 on the exam review on the EOC practice exam, and then we'll play another game on a different topic in Math 3. So I hope to see you tomorrow at 9 a.m. I'll send out the link. If you guys have any questions, I'm working on sending out the grading information, so you may see a survey today or tomorrow on that as well. All right, so have a good day, and I'll see you tomorrow.